Now, in this video, we're going to discuss the stability of electrons and why lower energy states are more stable. You've probably heard about this concept that electrons occupy lowest energy states first, and then they move on to higher energies because lower energy states are more stable. So, how does lower energy translate into more stability, or more stability translate into lower energy? Now, one thing to remember is let me give you a few examples which would be analogous to what we are doing over here. Now, stability means, what does stability mean? It means if something is stable, for example, you have a chair and it's stable, that means it's not going to fall down, it's not going to break, which it means that it's going to retain its state, or retain its state, or in other words, it's going to remain unchanged. So let's say I have a chair and there are two chairs. For example, this is one chair and here's another chair. Now, if you look at the chairs and this is your ground on which this chair is resting on. Now, if you look at these chairs, this chair is stable, whereas this one is unstable. This one would be considered at a lower energy, whereas this one would be considered at a high energy because it is stable. Now, since to look at these two chairs, you must question what we mean by energy. Now, when we talk about energies, we are talking about both these energies. We are basically talking about potential energy. We're talking about potential energy. Potential energy means that how much work can a thing possibly do. So if you look at this chair and you leave it, it's going to remain there forever until someone actually pushes this chair around. So this chair will remain in its position, it will retain its position, it's stable. That means that it won't do any work. Whereas if you leave this chair on its own, it's going to fall down, which means it's going to do some work and it has some potential energy. So this has more potential energy. This has almost zero potential energy. So when we talk about being unstable, unstable things are ones which have a very high potential energy. You can take many different examples. For example, there's a rubber band tied at 2 points. Now this rubber band, let's say this, write this down. It's a rubber band. I've tied it at 2 points, and there is another rubber band, and I've pulled it in between. Now this rubber band has been pulled in one direction, and this rubber band, if you just look at it, this one is the one that's unstable because as soon as I let go of this rubber band, it's going to do something. It's going to change. Whereas this one is stable. If I let this go, it's going to retain its position. That basically means that this rubber band had more potential energy stored in it, whereas this one had less potential energy stored in it. So there's another example. Let's take another example. We're going to move closer to how electrons and translate this entire concept of high energy and low energy, stability and instability to electrons themselves. Now let's look at two magnets. Now here's one magnet and there's another magnet, and they're close enough to attract each other. This is the North Pole, whereas this over here is the South Pole. And here are two more magnets, but this time what's going to happen is that they are already uh, join together at the two poles. This is the north pole, whereas this side is the south pole. So this is stable. If I let go of these two magnets, they're already stuck together, they won't do anything. But if I let these two magnets, leave them on their own, they're going to come together and they're going to join together. So they're going to do some work. So that means these magnets, this arrangement over here, this has more potential energy, whereas this one has less potential energy. Now coming back to electrons. Now if you remember all these examples, so if you look at an electron, this is a nucleus. If an electron is very far from that nucleus, let's say it's over here, that means the force of attraction between the nucleus and the electron, that's a lot. That means if you leave them on their own, the electron is going to get attracted and it's going to do a lot of work coming close to the nucleus. So since it's going to do a lot of work, that means it has more potential energy. Whereas on the other hand, if you have an electron which is lying very close to the nucleus, that would mean it has very low potential, because if you leave them on their own, they're going to get attracted to each other, but it's only going to cover a very small distance. So that means it's at a low potential energy. Now, one concept that you previously got from all the previous examples is whenever it's something that is unstable, it's always going to become stable very quickly. Whenever something is at a high potential energy, high energy state, unstable state, it's going to lose energy and become a more stable state. So electrons would occupy. Let's restate the concept. Electrons will always occupy lower energy states. So let's go through all the examples. This is at a high energy. It's in a high energy state. It's going to quickly become a low energy state as soon as you leave it. Similarly, this arrangement over here of the magnets is at a high energy state, and it's going to quickly become stable and reach a lower energy state. Same is the case with this rubber band. It's going to, as soon as you leave it, as you stop applying a force, it's going to become the low energy state. Similar is the case with electrons. Electrons further away from the nucleus are at a high energy state. They have more potential energy. Electrons closer to the nucleus have a low potential energy. So they're going to, as soon as you leave these electrons, they're going to come closer to the nucleus. So the final statement is electrons would always occupy lower energy states, which means that since electrons are now residing in orbitals, they will always occupy lower energy orbitals.